All right, in this video, I'm going to solve or provide a possible solution for solving the issue that was discussed in the lesson notes in terms of determining whether a tree is balanced or not. Now, what I'm doing is basing my tree on a class I've created called MyNode, which is using an existing class that is in the Swing library, which we will get into more detail with later on in the semester. The reason I'm doing that is that node comes with a couple of very handy methods that I can use by inheriting from that class. Specifically, it has a get first child and get last child. Now, what we're simulating here is a binary tree, and this particular class is eligible for a tree that could have any number of children. That's why it's worded get first, get last. There's also a get next child, but we won't need to use it in this case. So the implementation of my tree would have the first child be the left subtree and the right child be, or the last child be the right subtree. So all I have to do is repeatedly call those methods until I get a null value back. Count up the number of times I had to make that call, and therefore I would get the level of the respective subtrees. So let's make the method. We are returning an integer value. Remember, it is going to be a negative number if the left subtree is deeper, and it's going to be a positive number if the right subtree is deeper. So therefore, the way to get that is simply subtract the number of levels on the left from the number of levels on the right. If the number of levels on the left is bigger, we'll get a negative number. If the number of levels on the right is bigger, we'll get a positive number. So a routine will return an integer, and it'll provide us with the balance. We basically need two integers, which is the left level and the right level. Now that we have that, we need to create those two. So let's get the left level. So we will loop while we would receive a node, which we'd actually have to keep. So we're going to want a variable. So let's set that node. We need a MyNode item, which is a child. We'll only work on one tree at a time, so we only need one item. And we'll do that before the loop here. So we will use roots get first child method. So that gets us the left child. So while child is not equal to null, we want to increment left level. Now, just to be on the safe side, most compilers are going to initialize an integer at 0, but I'm going to set it just to be on the safe side. I've worked with so many different compilers in my career. I like to make sure I'm the one in control of what the initial values of my variables are rather than leaving it to chance. So, as I say, while we are getting a child, we increase the level, and then we get the next child, which is child's first child. That closes our while loop. That gets our left level. Now we do the same thing with the right level. We will set child equal to roots last child. That's the right subtree. And then while child is not null, we'll increase the right level. and get the next right subtree. That gets us values for right level and left level. So now all we would return is the value of right level minus the value of left level. This statement will perform this calculation and then return that value. So if the right level is deeper than the left, we'll get a positive number back. If left is greater than the right, if the left is deeper than the right, we'll get a negative number back. If they're the same, we'll get a 0, which is exactly what we asked our routine to do.